I can't keep a straight face. I can't.
Does that always happen when you have a camera?
Alright. Good afternoon. When you think of weather, you probably think of a scene like this. And when you think of meteorology, you probably think of a forecaster standing in front of a blue screen giving you a weekend forecast. However, there's a much lesser known aspect of meteorology called space weather. What? There's space weather, you ask? Well, yes there is. Hello, my name is Jessica Leiker. I'm a weather specialist in the United States Air Force, and space weather is something I deal with every day. It's a lesser known aspect of meteorology which I find fascinating. So today I'm here to inform you what space weather is and how it can impact us as human beings. First, let's cover the basics. Space weather is defined as the conditions of processes occurring in space which have the potential to affect the near Earth environment. These primarily occur between the Sun and the Earth, however they can also come from outside sources, for example, supernovas. Cover a couple basic terms. Sunspots. These are dark areas on the Sun. They're caused by localized areas of strong magnetic fields. They can last for years, and they're how we determine how fast the Sun rotates, which, by the way, it's every 27 days. They're also a precursor for solar flares. Solar flares are simply an explosive release of energy coming from the Sun. The last two terms I'm going to talk about are solar wind and magnetosphere. Solar wind is simply a continuous stream of particles coming from the Sun. Magnetosphere is the area of space where charged particles from the Sun interact with the Earth's magnetic field. Now, how is space weather caused? Well, unlike the Earth, the Sun is fluid. It's mostly gas. So when it rotates every 27 days, it's not like the Earth. So the equator has to go further around than the poles. This causes the poles to rotate faster and causes tension. When you get enough tension, it causes it to snap like a rubber band, for example, in the form of a solar flare. This sends a flow of charged particles hurtling toward the Earth. These interact with the magnetosphere. Now, on the daytime side of the Earth, this interaction causes the magnetosphere to strengthen, so you don't see a lot of impacts. But as these particles filter around the north and south poles or onto the nighttime side, the magnetosphere is weaker, so you get more of your space weather impacts. A good example that you're probably all familiar with is known in the northern hemisphere as the aurora borealis. Now that we've talked about what space weather is and covered a couple of basic terms, we'll go over how can it impact us. Now, there are numerous impacts, but I'm only going to cover three today. The first one is going to be GPS errors. When you get a space weather event, this could cause either damage to the satellite or can disorient it. And now, if the satellite doesn't know where it's at, it's not going to be able to tell your GPS unit where you're at. Second one I'll talk about is problems for astronauts. During a space weather event, a single proton can actually be deadly for an astronaut. The last one I'm going to cover is blackouts. Now, these charged particles can cause damage to generators and transformers. For example, in 1989 in New Jersey, a $36 million transformer was damaged and left 6 million people without power. So as you can see, the majority of space weather is transparent to most people. However, it has the potential to significantly impact our day-to-day lives. Like so much of meteorology, it's not fully understood and is very difficult to forecast for, however we do our best. So let's recap what we talked about. We talked about what space weather is, we covered a few basic terms and talked about its impacts. So I hope that this presentation has informed you what space weather is and how it can impact everybody, from the high-flying astronaut up in space to the lonely cubicle warrior. Thank you very much.